Hello and welcome to this recorded presentation for the McCloud data service. So how many times over the last 20 years or more have we been faced with yet another exercise to do, which means looking for old data, either in old systems or scanned images or files, so that we can find out old information to update members' records and recalculate and put right the level of the benefits that they're entitled to. Well, it seems that we're here again with McCloud Data Project, and the service and technology that you'll see today is aimed at taking away much of that data pain for you so that you're able to concentrate your resources on the more technical calculation and communication aspects of the project. My name is Andrew Marson, and I've been working with pension administration teams for over 30 years, working with them to help them improve their service and remove the barriers that prevent them from providing that excellent customer service that members deserve. So what do we see as the data challenges? Well, with the work that myself and the AIM team have been working on so far, is that we've decided that we want to focus on the data challenges because basically, that's the most important thing. It underpins everything that follows in the project itself. And we recognize that actually with potentially many thousands of records that you need to look into, it could be a very challenging and extremely time-consuming and costly exercise to do. So the sorts of challenges that we see pension funds are facing with this is that you could well have a number of legacy systems, both across administration and payroll. Endless lists of data interface files, for example, or your payroll provider may have even switched platforms in the time period that we're looking at, all of which adding a complexity to this piece of work. We also recognise that actually administration and payroll teams are already busy. And with plenty of other work to do in business as usual, and finding resources takes time, not just to be able to bring them in, but also then to train them up in what you need to do. And all of that against a pretty challenging timeline we think is a headache for the project. Now, when we're looking at the traditional methods of manual searching across records, it takes time, and inevitably with this is that we are human after all. We may not find all of the data, or even when we find the data, we could end up picking the wrong data, or it could be transcribed incorrectly. So we've always got that risk of human error. And what I've always found with these sorts of exercises is, well, actually, what's my confidence level like that I'm finding all of the data that we've got? And when you're looking to try and do this across potentially hundreds of participating employers within the fund, all of that traffic of backwards and forwards and engagement with the employers takes time, and there is the risk of errors or omissions. So those are where we see the challenges. So what is it about this McCloud data service? Why is it going to make all the difference? Well, dataBelt is the platform, that's the technology. It uses artificial intelligence so that it can actually look for data that's stored anywhere and everywhere that we tell it. So in that sense, it will find all of the data that exists. It doesn't matter if it's on traditional database systems or if it's in Excel sheets or images or phone calls or anything else. If it's there and if it's on the system, if it's on a network, and again we don't care if it's on your existing network or a different network, dataBelt is able to bring all of that data together, fully automating and consolidating that data for you, saving huge amounts of time and resource and cost. It is a piece of technology after all, so it doesn't care how many members that you're looking at. And what that allows to do, what we believe it allows teams to do, is to better plan because it can find all of that information in such a short space of time. It also means that the resources that you've got available for your project, you can concentrate their skills and expertise on the more complex pieces of work like recalculations and communications with members. The platform itself, you creates a hub so that all of your data and all of the work that is done during the period of the project is fully auditable and it's fully reportable. That gives you much better control. It allows you to report in terms of governance and show the progress that's been made. And there's also a full body of evidence that shows you all of the changes that have been made and is available for future reference and future audit purposes. So we feel that it's a very cost-effective and very time-saving piece of work, piece of technology and service that you're able to use here. And so that's why we're doing it. And now I'm going to hand over to Matt, who'll show you how it works. Thank you.
Hi everybody, it's Matt Smith here, Head of Pre-Sales at AIM. Absolutely delighted to be able to show you today's demonstration of how we use our tool dataBelt to solve the McCloud issue and provide a McCloud data service. So there are 5 different steps that we're going to broadly cover. The first bit, of course, is looking at and identifying the members who are actually in scope of McCloud. So what dataBelt is going to do is actually integrate with your scheme systems. In this example, we have Altair. And using a SQL query, we're going to say, out of, say, those 50,000 members, what are those 30% or so who we're interested in? We then go on to step 2, which is about enriching the data that we have in relation to those members. So we have those 30% that we're interested in terms of our project. What other data sources are out there that we can connect to? So possibly another integration with another system that's elsewhere, other internal systems that we have, maybe spreadsheets that we've been provided. The third step is around discovering other data that we have from unstructured sources. This is kind of like a secondary use case that helps support the primary McCloud use case here. And this is highlighting another feature that dataBelt has, which is around the indexing and searching of data. And it actually allows you to create an index of your entire data estate, everything that you have within your organization. And these could be things like emails, phone call recordings from the contact center, letters that have come in from members or employers that have then been scanned onto a drive somewhere. And it uses artificial intelligence and some really clever technology to index the content of that information. So not only does it allow us to save and index a phone call recording so that we've got the title of that phone call and when it happened, but it will automatically transcribe the conversation that was had on that telephone call and save it. So that if we're looking for, and we're going to have a look at this use case in a bit, but maybe we're looking for a particular member, we're going to search for their surname or their member number. If that was mentioned in the phone call, which of course it would be, we would be able to locate all the phone calls that we've had with that particular member. Similarly, if a letter was sent in from an employer relating to that member, and that gets scanned onto our systems, it uses something called optical character recognition, or OCR, and translates in effect what are those, the letters, the actual individual letters and the words that are within that scanned copy of that document. It then saves that, as searchable text. So again, if we search for a member number or something, we can then come up with that scanned document. So in effect, what we've looked at so far is identifying in-scope members, enriching them with data from all these other databases that we can connect up to dataBelt, and then also use dataBelt to perform ad hoc searches across our data estate to further improve the data quality of our McCloud members. That kind of covers off step 4 as well. That's all done as a single process with those ad hoc searches then added onto it. And then step 5 is around assembling that data in a suitable form and exporting it, or actually re-importing it back into Altair. So if of course the vendor permits direct access to the databases for updating data, then we can do that. We'll actually see that the job that we create in dataBelt here, the final action is to then re-import back into the system. However, because we do understand that that is not always possible, then we also have the ability to just extract that data as an Excel spreadsheet. So that's covering off what we're going to look at then in the demo. I'm now going to jump into dataBelt and show you how it works in practice. So I'm just starting off in our My View page, and this is for many people the landing page within dataBelt, because it gives us access to a broad range of services. Now you can see here, because dataBelt is a general data governance platform, it has a lot of distinct use cases, and these are sort of captured in the different colours that you can see here. So on the left hand side we have our data forensics and fraud detection capability. This is really useful for people like law enforcement agencies, for example. Our blue section around data classification and GDPR, of course, very useful to any organisation, as well as the data blueprint element that allows you to visualize and understand the data that exists within your organisation. And you'll also see, of course, because of AIM's experience within the pensions industry and the fact that we have this dataBelt tool which allows you to extract, transform and load data, we have a specific pensions data hygiene and compliance section. And you'll see that these different cards below here are the types of what we call microservices that are available within dataBelt. And naturally you'll see here we have our McCloud multi-data source cleanse service. And in effect all I do from this homepage is select which microservice I want, click proceed, and this will create a case. And I just wanted to mention, I'll say the word case a couple of times throughout the demo. Of course, many of us are used to that being a case that is to do with a member, so maybe a member query or an employer query. Cases are very similar in dataBelt. They are a vehicle to get us from A to B with regards to a specific request or action. So for example, when we actually create our McCloud case, that's going to follow us actually all the way through the data part of our McCloud project. We're also going to have a look at the data deep search microservice that we have here, and this is when we do our ad hoc searches. So if you remember from the introduction, the primary use case we're looking at here is finding our in-scope members and enriching the data that we have about them so we can perform our calculations, our McCloud calculations. That's our kind of primary use case, which is also supported by the secondary one, which is allowing us to perform ad hoc searches against all of the information that we contain within our organisation. So instead of me having to go back to a member or an employer to ask a question, if it's possible that we've had an email or a telephone conversation or a letter's come in that may answer that question for me, then I may as well use dataBelt to mine and locate that data for me before I go back and ask the question to the member or the employer. So the two case types we'll use here are these two that I've selected. Now there are just a couple of prerequisites, and these are things that happen at the start of the project to allow us to actually kick off the data work. And the first thing is to integrate dataBelt with your scheme system, in this case Altair. And I'm just going to click through within our configuration management database here to find that specific database for you. The configuration management database, or CMDB, just think of it as a repository of all of the sort of computers and servers and the like that exists within an organization. So it's like a map of the technology that we use to run our company, in effect. And of course one of those things that we've mapped here is the Altair database. So I'm just going to click through here, and you'll see it's this second record here that we're interested in. Now we've already carried out the integration steps. Very simple. You just need to tell dataBelt a couple of details about the database, give it some credentials, like like a username and password, for example. We've already done that, so that you don't need to see that part during the demo today. However, one of the things I will show you once it is integrated is the mapping of widgets to columns, and that will all become clear what I mean by that shortly. Now you can see down the bottom we've got a preview of the data that dataBelt can see from that Altair database. And of course we have a number of columns here with data in them, so I can see things like member titles, their first names, their last names, the national insurance numbers. And you'll see just above it we also have something else that looks similar. So we've got first name, last name, NI number. These are what we call widgets, and dataBelt ships with a number of different widgets, and part of the project of course is to create any additional ones you need. However, the main widgets are there out of the box. And what a widget is basically a definition of data, and what it allows us to do is to teach dataBelt about the database that we've integrated it with. And just to give you an example about what that looks like, you'll see here we have a Nino column within Altair. We have linked to the NI number widget, because it's called NI number within dataBelt. And what that widget does is it has certain rules associated with it. So for instance, a national insurance number, as we all know, has to conform to a certain regular expression. So although all national insurance numbers are distinct, they all have a similar way in which they're built, almost like a blueprint, like letter, letter, number, 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 etc. And what this allows us to do is not only teach dataBelt about the type of data that it's going to be ingesting, but also certain sort of transformation rules, and also rules about what that data should look like. So if we do ingest some data from elsewhere, and because dataBelt knows what type of data it's expecting, it knows what good looks like, basically. If that is of poor data quality, then we could choose not to use that to enrich our McCloud members, because, well, it could actually bring our data quality down. And as we go through it, I'll actually show you at the end what, from doing this process, how our McCloud data quality has increased dramatically, actually. Another example then, so it's not just about working out kind of the type of data that it's expecting and what it should look like, but it also has rules associated with it to say, if it looks like this, actually transform it into this. And a good example here is the sex column. So we've got male, male, male here. We've associated that with our sex widget, and that has certain rules associated with it. So in this case, we're expecting, possibly the word male or female to be used, as opposed to M or F or vice versa. And what this allows us to do is to transform the values that we're receiving in from the external sources into a data format that we need for Altair. So as an example, data coming over that says male, we may want that to read as M as opposed to male. So it has all these automatic validation and transformation rules associated with them. So not only are we training dataBelt on, by the way, this is the type of data to please expect, but this is what good data looks like. And by the way, if it doesn't look like good data, here's how you can transform it to make it even better. And that process is very simple. We simply click on here and you select the relevant widget, and you can see there are a number of widgets that exist out of the box here. Okay, so that is our first prerequisite. Now, our second one is around creating a template for what our McCloud project looks like. And I've already got one created, so I'm going to go to the case that's associated with this so that I can show you that template. And you'll see it's here that it's called McCloud Data Enrichment and Upload. And what it is a template or a definition of how we're going to be handling our McCloud data project. And it defines a few things, and I'm going to go through those with you now. It's in effect a three-step process. The first step is to define the data sources that we're interested in. So you'll remember we spoke earlier around defining what the in-scope members are from, in this case, Altair. And you'll see in the middle, one of our sources is actually a SQL statement against our Altair database to provide us with those in-scope members. So that's of course going to be one of our data sources. So we're going to be cutting down our 50,000 to those 30% that we're interested in. We've also got different data sources from elsewhere. Now that we've got those in-scope members, we want to improve the data quality of those members so that we can perform accurate McCloud calculations. And you'll see here we've got a couple of different data sources. In this case, we've got some CSVs, some spreadsheets. However, the number of data sources you can have here is unlimited. It doesn't need to be spreadsheets. It could be other databases that are either internal to your organization or external indeed. And so the examples we've got here, we've got a legacy payroll database here, and we've also got a council payroll database, both as spreadsheets and defined within our sources section. So that's the first step. Second step is also to define the destination. And you'll see here in this example we're going to be pushing straight back into Altair. However, as I said before, the option is always there actually just to export this as a CSV at the end, whether you specified this here or not. We've basically got the two options there: go straight back into the database or export as a spreadsheet. And then finally, if you remember when we were having a look at how we integrated dataBelt with our scheme system, and we went through a mapping process to tell dataBelt the types of data that exists within each of those columns, we do the same thing here. So for that council spreadsheet, for that legacy payroll database, we do exactly the same thing. So here's the information that it's pulled through. It gives you the top 5 or so records, and again we just go through and say, right, for this field we're going to map it to this value. For this column we're going to map it to this value. And again, as I said before, it's training dataBelt on the data to expect. It's importantly, those widgets are defining what good data looks like, and it's also defining what those transformation rules are. So if something comes in a format that we're not expecting, such as marital status or sex, for instance, we can translate those into values that Altair is actually expecting, so that our re-import process is considerably easier. So that's our template for our McCloud project. Now that we've got those two prerequisites done, then we can actually go ahead now and start creating our McCloud case and progressing our data project. So we of course want to go back to our My View page, because this is where we're creating our cases. And if you remember, we're going to launch a case here using the McCloud multi-data source cleanse microservice. And all I'm going to do is give it a name here. And we'll create that case. Now it takes me back to my case manager, which lists all the cases that I could possibly work on. And then all I'm going to do, because I want to progress this, I'm just going to click on the action button here. You'll see we have a number of different templates, and of course the template that we've just looked at is this top one, the McCloud data enrichment and upload template. So that's the one we want to run. So I'm just going to click on the jobs button here. And we're now going to create a new job. And a job is basically an instance of bringing data together, cleansing it and transforming it. And we can do multiple jobs within the same McCloud case if we wanted to. Fortunately, with the specific use case we're looking at here, where we've got our SQL query and our 2 spreadsheets, you could also throw in another database if you wanted to. They can all actually be done in a single job. But it's worth saying that as part of the McCloud data project, you could also do this quite iteratively, right? So you could do one job that is almost a test run with some test data. And then if you're happy with that, you could then create another job within the same case that of course handles the actual production deployment of that data. So I'm just going to give our job a name and click create. Okay, so we've now created our job, and you'll see just at the bottom half something very similar to that template that we created earlier. We've got our SQL query here and 2 spaces to upload our CSV data. And all we have to do now, because of course the data may have changed. When we created the job, let's say a week ago, the data in the databases and the data in the spreadsheets may have been different. So all we do now that we're doing a new instance of the job, is we're going to sync that data through. So I'm just going to click sync at the top here and upload the most relevant or latest versions of our CSVs. And you'll see that we now have our updated SQL query, so these are our in-scope members at the top. We also have our updated council and legacy payroll databases in the form of spreadsheets, also synced. And we're now going to go to the next stage, which is merging those sources together and processing them. And you'll see a summary at the top of how our data is currently looking. You'll see it's actually the data has been fed through 720 validation rules. So these are the different rules associated with those widgets that tell us what certain data needs to look like to actually be enriching our data, as opposed to actually bringing our data quality down. That's always very important, of course, when we're dealing with different data sources, because they could be poor data quality, or that data could be formatted in such a way that our final system, in this case Altair, is not expecting. And then scrolling down, you'll therefore see a validation breakdown, and you'll see a few different colours here. The red colours that you see, these are highlighting values that it is not expecting, and it also hasn't been trained on how to deal with it. So in the example here, in those additional data sources that we've merged with, we've got femaler and MLE instead of female or male. And of course, that is just not something we've trained dataBelt to deal with, because possibly we weren't expecting those spelling errors to be in there. And what we can do, if I just go in here, you can see it confirms what the error is. And I can now change this to female. And I'll also change this to male. And we'll come back shortly and we'll see actually it will automatically therefore translate it into a value that Altair is expecting. Which actually brings us on to our other values here that are in green. These are values that have been automatically transformed by the system. So the original value here was female. It's actually been automatically changed to F by dataBelt, because that is the transformation rule that is assigned to that widget. And you'll see a similar thing has now happened for our female and male values that we corrected. Similar thing here with marital status. This is just not something that we're expecting here, this U value. So I can go through and manually edit these to whatever they need to be. Or of course, if we do understand that those are the types of values that are coming from those other systems, then we'd simply just update the widget and say, you know what, when U comes over, we want to translate it to D. You'll also see a couple of, or 3 yellow boxes here. These are just warnings. So what we've said here, and of course it can be different for every organization, you don't need to conform to exactly the same rules we're talking about here. But these yellow sections are just warnings. So we're saying that we would like to have data in this field. We don't need to, however, and so therefore the fact that we don't have any data there is simply a warning, and these can be updated if they need to be. We can also do a duplicate check, so I'm just going to run that process now. If you think about it, we're pulling together data from multiple sources, And let's say, Matt Smith is a member in Altair. He's also a member in the council database and also features within the payroll database. That'll be great because it means we've got 2 extra opportunities to enrich the data that we hold on Matt so that his McCloud calculations can be done correctly. However, of course, the risk is that because you've got 3 separate MAT records, that you might upload those 3 separate MAT records back into your Altair system, which you do not want. You only have one Matt Smith, let's say, and you don't want to have suddenly 3 of them when you go through this process. And dataBelt deals with that through this duplication assessment. And what we're saying are, these are the widgets that we want to combine together, and you can tick or untick them depending on what you're looking for, to find Matt in his different sort of guises across systems and merge them together. So instead of having 3 mats that we upload to Altair, we'll have a single mat that has been enriched by data. So that duplication check has just run there, and if we have a look as an example, we have Reverend Monroe. We have this duplicate flag here being highlighted, and this is where we've got duplicate records that have matched that criteria from the other systems. Now if we just go over to the right hand side here, just to show you as an example, you'll see that the last day of service in our legacy payroll and council databases is the 14th of the 11th. However, we're holding a separate different value within Altair. Now we of course then have to make a decision, which is right, which is wrong. Now if we click on this value here, we've actually got the opportunity to merge that data together, possibly less likely for a date here, because that would actually throw a record if we tried to import that information in a merged format back into a date field. But maybe where you've got string information like a description field or a summary, you might want to merge that information together because both bits of information is useful. Or of course, if we say, you know what, the data quality of our last day of service in Altair is poor, so if it's that in another system we'd like to take it, or vice versa. Actually we're very confident in our last day of service data, we don't want to replace it. In which case we can just go across here and we're going to exclude that record, so we don't want to take any information from it, or we can choose to take certain bits of information if we like. So that's our duplicate check, and that's how we link members, who are in effect the same member but are just featuring in different databases together. That's how we train dataBelt about which data is better in which systems, which records need to be crashed together, and which records should we actually just exclude because we don't think it's going to be increasing our data quality. And then just another person that I want to look at here, another member, is Dr. Kirkby. And if we scroll over to the right here, you'll see we have our part-time hours. This is, let's say this is current part-time hours, and it has the widget associated with it. We don't know what her part-time hours are. And what this is going to do now is lead us into our secondary use case, which if you remember from the introduction, is around carrying out ad hoc searches against our organization's data estate to see if we know the answer to that question before we go off and ask the member, or in this case possibly the employer. And the first thing we need to do that is to create an index. And here is an index that we've already created, and you'll see this took around 3 seconds to run. We had 10 different files within the area of the organization that we were indexing. And if we just scroll down a little bit, you'll see we have a bubble chart explaining the different types of data that's been found. So we've got 2 .msg messages here. These are Outlook messages. We have 2 spreadsheets. We have a couple of audio recordings, and also 4 JPEGs, so image files. So now that we've indexed, and of course, as I said before, this would almost be a prerequisite anyway. This wouldn't be something that you do necessarily during the McCloud project. It would be something you'd have set up beforehand. We now enable our perhaps senior pensions administrators who are doing this data analysis to go off and perform these ad hoc searches to try and find any data that we're missing. And if you remember, we're currently missing Dr. Kirkby's part-time hours, and that's what we're going to have a look at to see if we've had any correspondence from her or her employer to help plug that gap. And then it just means it's one fewer phone call or email to make, and we don't have to wait for the response to come through before actually updating and enriching our McCloud data. And just to explain further about that indexing process that we've just gone through, this is a real-time visualization of what's happening when we actually run an index. So it's quite zoomed out at the moment, so there we go. As it zooms in, you can see these little people whizzing around. And what they're doing is these are workers that we've deployed into a customer organization. And what they're doing is iteratively going through file shares and databases, iteratively going through folders and subfolders. And whenever they find a file, a record, indexing the data that's relating to it. It's also running what we looked at earlier, OCR, so optical character recognition. So it's translating things like scanned letters into the actual words and text that are within them so that we can search on them later. It's transcribing conversations that have happened within audio files, so telephone conversations are being transcribed. And it's also running things like looking at emails and of course saving that data as text so that we can search on it easily. And that's all being saved into the index to support our secondary use case here, which is ad hoc searches of our data estate to try and plug any gaps that we have with regards to our in-scope members. So just as a brief reminder about what we've got to so far. So we've created our McCloud multi-data source cleanse case, and that's allowed us to pull together and define our in-scope members, pull together data from various different sources, and we're now in the process of enriching that data. From doing that, we found, although we have managed to pull through data from the council payroll database and the legacy payroll database, although we have managed to get that information, it has enriched a number of our members. We still have some ad hoc gaps here and there. And what we're going to try and do now is plug some of those gaps by searching our index that we've created. So I'm going to, if you remember, come back to our My View page here and create a data deep search case. So this is the second type of case that I said we were going to create. And in this case, we're looking for information that relates to Dr. Kirkby. And I'm now going to enter in my search terms. So I could be looking for anything that contains Kirkby, or I could be looking for Dr. Kirkby's national insurance number or member number. I can type that all into here. And you'll see that now that we've added Kirkby, we can also define something called a fuzziness level. So imagine, sometimes the employer gets the name wrong and they're called Dr. Kirby. We would still want to have them come back in this search that we're doing here. So I might say that actually one edit is allowed. And then on the right hand side, we define where we want to search for that data. In this case, it's within our file share that we've indexed. Down the bottom, we also have our query results. And if we have a look at the results of that query that we've run, you'll see that we've found right at the bottom here a number of different pieces of information that might help us solve our issue here with regards to Dr. Kirkby's part-time hours. Interestingly, you'll see our council payroll database and our legacy payroll database right at the bottom. Our spreadsheets have been returned because, of course, Dr. Kirkby features in both of those spreadsheets. But the main thing here is we have a .msg, so we have an Outlook message, an email. We have an audio recording. We also have a photograph, a .jpeg, which is of a letter. And so I'm going to go through these now and see if these can help me with my conundrum. So the first thing here, we've got a .msg. So this is a message. This is an email. And if we have a look at it, this is from John Smith, the HR manager at Dr. Kirkby's employer, confirming part-time hours. I can also download the original if I want to and view the original email message. I also have access to a phone call. Let's open that up and take a look. And the really interesting thing about this is that the phone call, I don't need to sit here and listen to it. The phone call has actually been transcribed automatically by dataBelt. You can see the answer to our question here. I can also download the original, and that's been automatically indexed and transcribed, and it's allowed us, of course, to then run a search and find this data. And then finally, we also have a JPEG. We have an image file here, and you'll see here it's also transcribed. The really interesting thing about this is that it's understood the the shapes and the words and the letters that are within that original file, and it's been transcribed so that we can then search on it as we have done here, and it's come back in our search results. Let's download the original and have a quick look at that. And there we go. We therefore have the original letter from Dr. Kirby's employer confirming part-time hours. So I think we now have the answer to our question. I can therefore go back and progress our case now that we know this information. And we can simply add in Dr. Kirby's part-time hours into the field. And then we have a couple of options. We can perform matches, which allow us to do what's called an upsert, so an update and an insert into our Altair database, which, if you remember from our template, was our destination. Or quite simply, we can therefore choose what we want to export. And in this case, I probably want to export all source rows, and then I can do with that as I wish, or whatever process I need to go through to get that back into Altair. And then finally, if we open up our quality check report, this is something that we can use to track our data quality throughout the McCloud data project. And this shows us that actually currently our dataBelt quality index is showing at 99.53% for our in-scope members. And that's based on those widgets that we assigned to the different columns within our source databases and spreadsheets. Well, I hope that run through was useful. If you do have any further questions on how AIM dataBelt can help you with your McCloud data project, please don't hesitate to get in touch, and we'll leave our contact details at the end of this video. Thanks again.